Hello everyone and welcome aboard this introduction to the world of cognitive services. My name is Lior Armaev and I'm a cloud architect at Cloud Valley and an AI MVP. And today I'm here to introduce you to this amazing world of machine learning as a service, or as better known in Azure as cognitive services. The purpose of today's session is to show that it doesn't matter how big or small your idea or application is that you don't need a big team of data scientists or any knowledge on machine learning and deep learning in order to make magic with your own application. So with no further ado, let's start with the agenda of today. And of course, we'll start with AI in the world of Azure. We will continue with cognitive services and the different services that are provided by Microsoft, and there are many of them. And I will wrap everything together with two demonstrations that I have, one with cognitive services inside of a code and the other one using cognitive services inside of a container. So I assure you it will be fun. I want to start with a small funny slide that I created about AI, because there are a lot of question marks about AI and how we implement it, how companies can benefit from it, how the end user can benefit from it. And because not everyone are data scientists and no one is an engineer in the field and can create models in machine learning and deep learning, I can show you that it's quite simple. It's enough to have an idea and a concept and, some kind of knowledge in writing code or working with REST APIs to start and work with a machine learning as a service like the cognitive services. So starting from the top, AI, what is it? AI is any technique that enables computers to mimic human behavior. So it's an idea, and this idea is with us from the 50s with formulas that we use in mathematics from the 19th century. But there is a reason why we now use machine learning, that is a subtitle inside of artificial intelligence, and this is a compute power. We had bigger computers, stronger, we have cloud computing, this is available for everyone. And we started to see a bloom in this area because we have all of this compute power that allows us to train more models that are better, faster, more efficient. And machine learning changed a lot in the way we work with the computer. So if we had before that, we have data and we need to write procedures to have an output. So if we have the data, then we write the if and then situations for any situation. We write the code and then it will provide us with the output. What machine learning introduced is the way to use statistic models and the way to classify the information. So we now use data. We have the data and we have the output, and we allow the computer to calculate the algorithm by itself. And instead of trying to understand what the computer did, we use already the trained model to classify. So the best example is we have pictures of cats and we have pictures of dogs, and we train the computer saying, okay, this is a dog and this is a cat. And when we introduce later on a picture of a cat that we didn't train on, it will say, okay, the probability and the classification for that is like, this is a cat. So this is what machine learning does for us, and it's getting better because of deep learning and neural networks. And as the computer progress and the cloud progress, we have a lot of innovations and a lot of breakthroughs in this area. Azure is not resting. It's always evolving, and in Azure and AI there are a lot of innovations every time. So even this chart, it probably changed already a few times, but the idea is simple. We have the infrastructure, the computers, there's the data that we use for the AI, for the machine learning and deep learning. It starts from the servers that run GPUs and CPU and FPGAs. We have the infrastructure like Spark, we have Cosmos DB, we have all the options to run our models, to make our models, to run our experiments. And this is the infrastructure that is provided by Azure. Of course, we have all the tools. So we have the machine learning studio, so we can create our create models. We can use Databricks, that is not here in the picture, but we use Databricks as notebooks, to creating experiments for people that not always know how to work like with code, right? So they know their like mathematics and they don't need to program anything. And we have the AI services. So in the AI services, we have, of course, cognitive services, because the idea of machine learning as a service is to provide something that is already pre-trained. It's pre-trained with millions of pictures, is millions of records of data that is already pre-trained by Microsoft and by the customer itself, so it can be used later on by you simply by hitting a button on the REST. So you have a REST API that just goes to the service, asks for the classification, for example, and gets out the output. The same goes to the bot framework. That is a free framework for bots that can be very sophisticated if you combine it with the machine learning of cognitive services or any other model that you have. Combine it with the communication channels like Skype and Teams and any other, and you have a very, very sophisticated bot that uses AI to answer most of the questions that a customer can ask, and only in the case of like the 10%, it will go and you can introduce the support directly to the client through the bot. Okay, and you have the machine learning studio that is very simple if you just want to create models by dragging and dropping on the canvas. So it's very simple to use. And moving to the main part, that is cognitive services. And what is it? Cognitive services, as I already mentioned, is a simple machine learning as a service. It provides you with an API, a REST API that you can use, and you, the programmer or developer, you don't need any knowledge in AI. You don't need the infrastructure for AI, you don't need a strong compute power, you don't need to think about the high availability of it, you don't need the teams, you don't need the data scientists, you don't need the data. And in the end result, you have a very simple blocks that you can use to create your own service. So if you have your own application and you want to pump it up, or you have an idea and you want to prove a concept of an application that you have on your mind, cognitive services will allow you quickly to get to the point where you have, first of all, a running application with AI, and later on you can modify it and add more services. If I take a chatbot, for example, the first thing that I want to introduce in a chatbot is maybe language understanding. Later on, if I introduce my chat in other countries, I want to add translation and maybe some kind of a content moderator if I get images inside of the chat, or any other service. And it's very easy. I can add a new service, I can remove a service, I can change it to something else, and I don't need to think about the infrastructure or how do I expand it. Does it support other countries or anything like that? And I don't think about it because I just add an API and that's it. So on the code side, it's just adding few more lines and the model is ready to go. In cognitive services, there are 5 pillars that the service is running on. So you have the vision, the knowledge, the speech, the language, and the search. Of course, there are labs, but the labs are more for preview of new products that are going to get the category by itself or maybe be added to a category that already exists. And of course, I will start with vision, the one that people talk about the most. Vision holds 6 services. Computer vision is the first one, where we just introduce an image and we make some kind of classification. We can create a description about an image, we can read license plates, so it's OCR capable, we can understand landmarks and descriptions and celebrities and scenery and everything concerning the image and what is in the image. Ink recognition is a service that allows you, as said, to recognize handwriting, and this is a very useful thing. Custom vision is when you don't really want just to classify an image saying, okay, this is a dog or a cat. you can say, okay, I have a production line and I want to see that the product it is exactly the same, so there's no defect. And how I do that, I introduce the images of the right product, and then if the computer vision in the custom vision will see something that is different, it will say, okay, something is wrong here and you need to take an action. Face is an add-on to computer vision where you can add face detection and face recognition, so you can understand who is in the image and where he is standing, and does his his emotion, is he smiling, or I don't know, is he sad. So this is the face recognition. Video indexer, the service is for video content, so you can upload in a video file and you can get a lot of the information that you have in computer vision. You need to understand that in computer vision, video indexing is a little bit more difficult. Why? Because you have a frame change, and video indexing is making this calculation of what happened in the frame before that, and this is why video indexer is a little bit more difficult than a simple computer vision. And you have form recognizer. It's a new service. It's a very good one that in many companies I get those paper forms that you need to fill up, and the problem is that someone is later taking those forms and just typing them in the computer. So instead of using this method that is time consuming, you can just take a photo of your form and it will extract the text and use the pairs, so it will see like some kind of a column with tables saying, okay, this is the key, this is the value. Very simple. Moving on, we have the speech services that include speech to text and text to speech, and of course the real-time transcript, and this is very useful. We use it in a lot of applications. Speaker recognition is very useful too, because we can understand who is the speaker. So if I talk to my bank, for example, there is a service for speaker recognition that identifies that I am who I am, and this is done with the speaker recognition. Language services, they are divided in a couple of services that are very, very cool. First one is the text analysis, that is looking on the sentiment of the sentence and making an assumption about what has been written. So if you have reviews and you want to know if they are good ones, bad ones, if there are bad words on it, and I don't know, some kind of a moderator to the text that you have. Translator is very simple. You translate from one language to another. And of course, the service that I like almost the most is language understanding, and it's called Lewis. And what it does is very simple, but it's very hard in like recreating it in simple scripts. When you have an input from a customer, sometimes you need to parse it, and the way to parse it is not that easy, because if I'm talking about flights and I want to order a flight and I write it down, I say I need a flight from New York to Washington for 2 people tomorrow and back in 5 days. How do I parse something like that? There are a lot of problems. I don't have an input and output of a simple date, because I say tomorrow and I need to understand what is the date tomorrow, and I need to understand when I say New York, and sometimes I will write down NE or maybe DC instead of Washington, and there are a lot of variation of text that I can use as an input. So language understanding engine will allow me to understand the sentiment and the entities and the phrases that I use, and it will extract the data, so I can now know what is the destination and what is the source, and when like the start date and the end date and number of people. Everything is done in this engine, and I'll show you in the demo how I used it in the container, because containers are supported in cognitive services. Moving on to decision making. So in the decision making, of course, we have the content moderator is using text and images to moderate it for, I don't know, something that is adults, for example, adult content, and I need to understand if I need to do something with the image before I upload it to my service. Anomaly detection is very simple. We have a lot of information coming from IoT devices, and I need to see any anomaly that is happening. So if there's a peak in CPU or some information that shouldn't, like, is not in the normal like baseline. Q&A Maker is a very interesting service that is almost like the LUIS, like the language understanding service, where I can take all my knowledge base, my PDF, Wikipedia, every knowledge that I have in the company, and I create some kind of a Q&A engine where I can upload everything over there, and if I have any question, I will get an answer that is the best suitable for my question. So the answer is most suitable for my question. If it's not the best one, it will allow me to choose between options and saying, okay, maybe this article or this one is better. So Q&A is the best. Search is very simple. A lot of search options, searching images and searching news and web, and everything concerning search is in the search category. Everything is done by Bing. I know that some people saying that, like, it's Bing, like, who is using Bing? But if not looking on the interface between Bing and Google, for example, on the background they are doing the same. So I don't see any reason why not to use Bing. There are the experimental, of course, but I will not enter them because they are changing and they're experimental and they evolve, and some of them will go away and some of them will be added as a public service. Containers, and I think this is the most amazing stuff that was added not a long time ago into cognitive services, and the container support is very nice because I myself use a lot of containers in many services, especially in the cloud. But the main problem with cognitive services and the cloud by itself is that it's in the cloud. It's not exactly the best response time sometimes, because maybe I'm sitting in a place or a country where the internet service provider is not the best. So I cannot think on a service that I provide to a customer that will be based on the idea that, okay, he was writing something and now it goes to the cloud asking something and then gets a result, and then my program continues from this point, right? So it's an asynchronous transaction. And what containers allows you to do is to take the engine of a service and to run it locally. So you can run it in the cloud, but you can run locally on your site. So of course it will bring your service to a higher level in efficiency and speed and latency and everything that you can think of. And cognitive services allow that in many of its services, and I will show you a demo of that. Alright, so I want to show you how the cognitive services work with the containers, and I will start by using the LUIS language understanding engine that is using an application that I built as a demo for a railway application for ordering tickets. And here I can test an option that I have to order a ticket. So I have I want a ticket from Tel Aviv to Haifa, right? Haifa. And what it does is checking with an engine that are like a pre-trained model that I used with sentences of buying it, purchasing a ticket. So I'm saying I want to buy a ticket, so it understands that I want to buy a ticket from Tel Aviv as a source and Haifa as a destination. Okay, this is what LUIS does, and it's a very powerful tool, but it's doing it on everything online. but I want to do the same locally. How do I do that? I need to spin up a Docker container over here, and I have already the commands here for the Docker, and I run it. The moment that I run it, I can go locally on my machine, and I have this Docker with Lewis running on it. So I go to the Swagger file, I can run a test here for my application. So I need some information to run it, like the application ID and the question. So I need a train, or I need a ticket, right? Ticket from Tel Aviv to Haifa, right? And let's execute it. All right, let's go down, and what do we see here? We see the same thing that we saw on the internet. You know that the intent of the sentence is to buy a ticket, and it's almost 100%. Then it knows that the source station is Tel Aviv and that the destination is Haifa, right? So this is all done locally, and this is a time saver, and of course a very, very big progress. And as I know, there are no such option in cognitive services and other providers. So big thumbs up to Microsoft on that. One more thing I want to show you is how we implement cognitive services in VS Code. It's quite simple. It's just a matter of adding a few lines, and that's it. I wrote the program in Python, and the reason is because I use OpenCV as my first engine for face detection, so I can reduce the cost of my cognitive services by first doing some capturing of my face with an open source machine learning engine, and then only moving the frames outside to the cognitive services. And I will show you a demo of that. And if I run the program and I do a face detection, hi everyone, and you see that it's looking on the attributes that I have, so the properties that I have about the image. So the first triangle itself is done by the OpenCV engine, and later on I moderate it and add the cognitive service around it. And it's very easy to do, and you can see the attributes that are coming from my OpenCV engine and from Azure. And I will go to the debugging mode and show you that. And right, and as I open it, you see the cognitive services, the credentials, and face detection. And if I go to the face detection, you see a lot of attributes. So there's the age, and this is exactly my age, and if there's hair and glasses and whatever. And this is exactly the reason why I use cognitive services. It's very easy. It's just a few lines of code. Don't be intimidated by that. It looks frightening and a lot of code, but the idea is that before I send the information to the cloud, I want to make clear that the images that I send are exactly the images that I want to process, because I'm paying for any process that I do in the cloud. And this is why I use OpenCV. I want to detect new faces in the image and faces that are not static. So if I take this example, this is a picture of Times Square, and you see a lot of billboards, and on some of them there are faces. The faces will be there 24/7, and the problem is that the algorithm will see the faces and always will send them to the cloud, and by that you can get to the point that you always send information to the cloud, and then the expenses skyrocket, because you're always sending, you're always detecting, and it always detects the same picture, the same person, and not something new that is happening. And this is why it's very important, and it's a good tip from me to you on using cognitive services. Try to filter out, try to sort, try to scope what you send, and use different models, but use it wisely and understand what is happening in the image that you're sending. So in the case you're using images. So I want to make a summary of what we had in this session about cognitive services, and I want to go through the strengths and weaknesses of cognitive services and why I should and shouldn't go with this kind of service. And I will start, of course, with the positive. The first and the far most important is that it's a managed service. You have everything pre-built. Everything is ready as an API that you use. You don't need to have any knowledge about AI. You don't need to train any models. You don't need to bring data to train on. You don't need to do any kind of work besides using a service that is already pre-built and done. So it's scalable and it's easy to use, and this is the main reason why I love cognitive services. If you have an idea, just run with it. You have a lot of free tiers that you can try out with a lot of options where you probably will try your application for, like, you have an idea, you only try it out, and you don't pay almost anything on trying a new service. You don't need to bring a team, you don't need to train anything, and if it works, then you can scale and continue to work with cognitive services. Of course, another one is the idea of using containers when, if there is a problem or there was a problem with the compliance and you have like HIPAA and many certifications that you need to comply with. First of all, the cognitive services is certified on those certifications, but as a company, maybe you cannot allow yourself to get the information out, so you have containers. Not all the services have containers, and this is why there's a weakness still in cognitive services, that not all the services run on containers, but it's something that grew up, and more containers will be available later on. And as you see, it's relatively cheap. As I said, you can start with a free tier, and even when you get through the free tier and start working with an application with end users, it's still sometimes costs less than when you compare it to having a team of engineers and the data and the compute power that you need in order to have your product running. So sometimes cognitive service will be easier to use and cheaper. About the weaknesses, I said about the compliance, but it's a matter of technology, so I think the containers will be soon covering this problem of information being sent to the cloud and using all the compute power on your side. But one of the most annoying problems in cognitive services is that it's general. Because you support millions of people and you don't really create a custom-made service for everyone, you create some kind of a template that will work for like 70-80% of the people, but if you want more features, some more I don't know, tweaks inside of the service, it's impossible, because it's made as a general purpose and you need to know it before you go to the cognitive services. So maybe for testing purposes, or maybe for an application that that doesn't need all those tweaks, cognitive services will be a very good solution. About the connection, you're working with the cloud, so it always depends on your ASP and how you connect to the internet. And about the pricing, you need to understand that the example that I had about the Times Square, this is why it's very important to notice what you send to the cloud. So before you send the information that the client or your company provide you and you want to make an analysis on it, you need to filter it out, you need to sort it out, you need to scope it. You need to understand that you send only the data that you want to be analyzed, because you pay on anything that you compute. So in the matter of weaknesses, pricing is a problem if you just send all your data to the cloud. I want to say thank you very much for being with me on this session. I didn't have the time to go through all the points about cognitive services, but I do encourage you to go and learn and try it out by yourself. If you have an idea, just go with it. There's a lot of stuff that you can do with cognitive services and in AI as a whole. Don't be intimidated by this two-letter word. It's still very easy to learn, and a lot of material with Microsoft that can help you in the world of AI and in cognitive services and bots and everything. There's a very big community, and everyone will be more than happy to help you with. So thank you very much, and see you again next time.